In this class, we're going to consider the notations we use to represent the derivative. So it's fairly straightforward. Basically, if a function is given to you as f of x, then we represent the derivative using the notation f prime of x, or sometimes this is called f dash x. But basically, if you get an f function using this function notation, this is how you'll represent the derivative. It doesn't have to be the letter f. I mean, you could potentially have a function, say a g function, or indeed any other letter. So if you had a g function, then the derivative of that function would be represented as g prime of x or g dash x. Personally, I prefer to say g dash x, but g prime of x is fine as well. So these notations basically go together. If, however, the original function is represented as, say, y equals, so y equals 2x plus 3 or y equals x squared or something like this, then you'll use the notation dy dx. And you may have seen some of these notations already as we've done things like define the derivative or define differentiability. If you've been watching some other videos in this series, so you might already know kind of what these mean or where they come from. They basically come about as a different approach to calculus, so a historically different approach, but they effectively mean the same thing. The way that we arrive at these two notations thinks about differentiation in a slightly different way, but you don't really have to worry about that or think about that. All you need to know is that if a function is given to you in this format, then this is the notation we'll use. If it's given in this format, this is the notation we'll use. The actual mechanics of this is not massively important in terms of taking derivatives. In the context of a Calculus 1 class though, because you've already perhaps looked at videos where we discuss differentiability and the kind of lead up to where the concept of a derivative comes from, then it is maybe important to think more about the subtleties of these. As you get into calculus though, that will probably get backgrounded and you'll think more in terms of just taking derivatives using different differentiation rules, which we're going to look at in subsequent videos. So the primary idea here is that these notations go together. And again, this guy here, this would assume a function y given in terms of x, but you could see variations of that. You could have, for example, a derivative like dt over ds or something like that. I mean, it could be all sorts of letters. There's no restriction only on a y. It's just that we tend to use x and y, because we've got an xy axis, and that's how we define our functions. So these are our two primary notations. So some variations you may see on this, just to make you aware of those in case you do see them and you think like, what is going on there? I thought there was only two ways to define the derivative. So one variation that teachers tend to use, particularly if they're going very quickly through a question, is to kind of combine these actually. It's sort of a shorthand thing where they'll just say y dash or y prime to represent the derivative. So it's kind of using the prime notation from here, but using the y from here. But that's not really formal notation. You would never present your answer in that way. I wouldn't have thought. Your teacher would probably not recommend that. You should be using one of these notations. This is more shorthand. And as you get further into calculus and you start taking multiple derivatives, like higher order derivatives they are called, then you might use this notation more because it is convenient to take a second derivative like this. So y dash dash, or a third derivative y dash dash dash, I guess. But that's really just a shorthand technique more than anything else. Another thing you'll see is if you want to imply that you're taking the derivative without actually yet taking it, then we can use the notation, so d dx, and then here put our function. So I'll maybe put that in a bracket and put f of x like this. So the reason why this might be important is if you want to write a statement which implies that you're going to take the derivative but you've not yet taken it, this can be a good way to do it. So for example, if we had a function f of x equal to say like 2x plus 5, we can now go ahead and take the derivative. Now, you've probably not yet reached the rules for differentiation, so I'm kind of jumping ahead here just to show the notational difference. But if we take the derivative, we represent it, in this case, because we had an f function represented this way as f prime of x or f dash x, and that would come out to be 2 just 2 in this case. And you'll learn why that's 2 later on. We're not worried about that here, but that's your only option with the notation. This was a function, this represents a derivative. If you wanted to say though, I'm going to differentiate this function, you could write it as d dx, derivative with respect to x. That's how we say that. That's how we say this as well, by the way. This is the derivative of y with respect to x, derivative of t with respect to s in this case. Usually we don't have to say those words out loud, but that's how you should kind of say it in your head. So in this case, we would say the derivative with respect to x of the function 2x plus 5. So that kind of says, I'm going to take the derivative of this with respect to x, but I've not yet taken the derivative. It's quite a subtle difference, but this is just the function. This is just saying, hey, I'm this function. This is saying, I'm the derivative of this function. This is saying, I'm going to be the derivative once you actually take the derivative, but you've not taken the derivative yet. This is like the intention to take the derivative. Initially, this notation might not be all that prevalent in your work if you're just starting calculus and differentiation, but you will see it before too long, so it's good to know about it now. And then you would just say, right, well, I'm taking the derivative with respect to x of this, and the derivative would still be 2, but you've kind of captured a slightly different way of thinking about it in that sense. There are a couple of other options for the derivative. These tend to be the main ways that you'll see it represented. You might sometimes see a capital D with a little x, so that again means derivative with respect to x of maybe some function in here. So derivative with respect to x of y in general, but this could actually be some function like 2x plus 5 in here as well. So these are all the variations on the notation. It can be a little overwhelming at first because you're trying to learn what differentiation is, you're trying to learn how to take derivatives using the differentiation rules, which we're going to look at in subsequent classes after this class, but you're also at the same time just trying to figure out the notation because you'll never have seen any of these before. So just bear in mind that these are really your primary 2 notations, and you're just going to use those depending on how the original function is presented to you. All of these other variations are just things which you need to be aware of at this stage, and as you actually get into using these, if you've got a need to use them for a particular topic, then you'll be looking at them in that topic anyway. So this is kind of just prep work. This is just a bit of an overview of the notation, just to help you take those first steps into differential calculus without thinking, what's going on here? Like, what does all this weird symbolism mean? So just to kind of get you prepped in your mind so that you've got an expectation about the types of things that you'll be seeing, because it can be quite off-putting and quite intimidating when you're already trying to learn a new technique, and then you've also got to take on this kind of new language at the same time. So we just want to get this out there now so that you know what to expect. So hopefully that makes sense. The next goal for you really is to move on and start learning some of the rules. And the first rule we're going to look at is called the power rule for derivatives, and we're going to look at that in the next class.